Okay, now we are going to get into solving some of these equations when the bases are not equal to each other, all right? And so in these first three examples we're going to just have to change one of the bases in order to make these work out, okay? So in this first one, you've got 5x to the minus 6 is equal to 125. And you'll notice that over on the right side here, I have this little table that I made before I started the video, right? And it's just you put in your number for x. I went up to 15. This shows all your x squared values, and this shows all your x cubed values, right? And so these might come in handy for us to sort of figure out some of these things. So the goal is to be able to write these with the same base. And generally speaking, what you have to do is you have to simplify one to get to the other, or you have to simplify them both in hopes that they're going to have the kind of the same base at some point. So in this one, 5 is already about as simple as it's going to get, right? Because it's a prime number. But 125 can be simplified to 5 cubed because it's 5 times 5 times 5, right? So we can rewrite this as 5 to the x minus 6 equals 5 to the third power, right? And then once we have that, just using what we learned in the last video, we know that we can drop the bases and set the exponents equal to each other. And then add 6 to both sides, okay? And then that gives you x is equal to 9, all right? So if that's the case, let's figure this out. So 5 to the 9 minus 6, well, that's 5 to the third power, and I know 5 to the third power from this is 125. Is that equal to this? And yes, it is. It is equal to 125. And so it checks out, all right? And so that's why having a little table like this might be helpful to you. You know, maybe write it in your notebook somewhere or have it somewhere so you can use it, okay? Next one, we've got 2 to the x is equal to 8 to the third. So what we're going to do is I'm going to rewrite this as 2 to the x equals, and then I'm going to put 8 in parentheses, and you'll see why in a second, 8 to the third power. Because I think I can write 8 as a 2 to the power of something, and sure enough I can, because it's 2 to the power of 3, right? And a lot of these you're going to be doing like powers of 2 and power of 3, and so, you know, even for that, it might be helpful to go, well, you know, 2 to the 1, you know, 2 to the 2 is 4, 2 to the third is 8, 2 to the fourth is 16, you know, just do some powers of 2 and maybe even do the same thing with 3 and 4, just because you'll have to play around with those, right? And so if I know that 8 is 2 to the third power, I'm going to rewrite this inside here. I'm ignoring this because I'm just dealing with what's in here. I'm going to rewrite this as 2 to the third, and then you have this right here. So I replaced this for this, right? I substituted this. So in doing that now, remember what your power of a power rule is, which is you when you're taking the power of something, because this is basically saying 2 to the third 3 times, right? Multiplying, and you would just add your exponents. Well, the ninja way is to take this and just multiply them, right? Go 3 times 3. So this gives you 2 to the ninth and equals 2 to the x. Well, now that your bases are equal to each other, you set your exponents equal to each other, and this is already kind of done for you. So now let's just see, is 2 to the ninth actually equal to 8 to the third? And if you put these both in your calculator, you will in fact see that 2 to the ninth is 512, and 8 to the third is also 512. All right, so these do work out pretty neatly. They're supposed to, that's the idea. But you definitely got to play around with these a little bit. Okay, now this last one here, we've got 3, which is kind of simplified. It can't be written as a product of anything, right? And we've got 9, which can be written as 3 to the second power, right? And we actually like that because then that means that these are going to have the same base. So I'm going to rewrite this as 3 squared, all right, to the 2x minus 1 equals 3 to 6x. So we know from our power of a power rules that we take this thing right here and we're going to multiply it by this thing, right? So we're going to have 2 times 2x minus 1 is going to then, that's going to be equal to this 6x because these bases are the same, right? So this is going to give me 4x minus 2 is equal to 6x, not 64. All right, they do look a little bit alike. And then we're going to subtract 4x from both sides. And you'll get 2x over here, and you'll get negative 2 right here because these cancel. And then if we divide by whatever my coefficient is in front of my variable, which is positive 2, I get x is equal to negative 1. So let's put that in and see what we get. So we have, and I'm going to have to put it in the whole thing now, right? 9 to the 2 times negative 1 minus 1. Is that equal to 3 to the 6 times negative 1? So this is 3 to the negative 6 power, all right? And then this is 9, so this would be negative 2 minus 1, so negative 3. 9 to the negative 3rd power. All right, well, what I know about negative powers, right, is that writing this is the same as saying 1/9 to the 3rd power, and this is the same as saying 1/3 to the 6th power. All right, and so let's, I'm going to finish this off over here. I'm going to figure out what 9 to the 3rd power is in a second. I'm assuming it's going to work, but like I said, I like to, and actually, if I already know what it is because I have it right here, right? So I have 1 over 729, and then I have 3 to the 6th power. So you just go 3 times 3 times 3 times 3 times 3 times 3, which also equals 729. So you get 729 equals 729. It checks out. So that means that your answer of x equals negative 1 is good, right? And so your answers work out, and we're a happy camper. So like I said, look for, which one can you simplify to make it equal to the other one. Okay, and we will pick up with the last video in a moment.